Have you ever gazed upon a newborn, so tiny and perfect, and found yourself wondering, how does that happen? It's a question that has fascinated humanity for centuries. One moment, there's seemingly nothing, just potential, and approximately 9 months later, give or take a few weeks, there's a whole new person ready to face the world. A person with tiny fingers, each one perfectly formed, a beating heart, strong and resilient, and a brain full of potential, ready to learn, grow, and experience life. It's not magic, though it certainly feels like it. It's science. A complex and beautiful process. A process that turns something too small to even see with the naked eye into you, me, or anyone you know, each with their own unique traits and personalities. You didn't just appear out of thin air, fully formed. You started as something smaller than a period on this page, a single cell holding all the information needed to create you. From that tiny speck, you grew a heart, pumping life-giving blood, lungs, allowing you to breathe, a brain, the control center of your being, and even your own unique fingerprints, a mark that sets you apart from every other person on the planet. This transformation is one of nature's greatest performances, a carefully choreographed dance of cells and genes, a biological masterpiece perfected over millions of years of evolution. Understanding this process is like getting a backstage pass, a VIP tour to the greatest show on Earth, the creation of a new human life, a spectacle of growth and development. So where do we begin this incredible journey of discovery? With the science that studies exactly this intricate process. It's a field dedicated to understanding, unraveling the mysteries of development, the step-by-step instructions, the genetic blueprint that build a living creature from the very first cell. This journey is packed with more action and transformation, more twists and turns than any superhero movie, filled with incredible feats of cellular engineering. Every person on Earth, regardless of background or origin, went through the same fundamental stages, our shared beginning, a common thread that connects us all. Let's dive into the science of how life begins, exploring the wonders of embryological development, from the first spark of fertilization to the final countdown before birth, the culmination of months of growth. And it all starts with a simple yet profound question: how? The science with all the answers? Embryology. That's the study of how an embryo develops. An embryo is what we call a developing baby in its earliest stages, right after it starts as a single cell. Embryologists are like life's architects, studying the blueprints and construction process that builds a living thing. They watch the journey from a fertilized egg to a fetus, frame by frame, to see how everything comes together. How does a heart start beating? How do nerve cells form a brain? These are the mysteries embryologists solve. By understanding how we're built, doctors can better help when things go wrong. This knowledge helps prevent birth defects and keeps babies healthy, even before they're born. Embryology is a dynamic, exciting field, constantly revealing new secrets about how life works. It's the science of you, me, and everyone we know. The incredible journey of life begins with a single, pivotal moment: fertilization. It's the spark that ignites a cascade of events, transforming a microscopic entity into a fully formed human being. This remarkable process occurs when an egg, carrying the mother's genetic contribution, and a sperm, delivering the father's heritage, finally join together in a moment of biological destiny. This union culminates in the formation of a single cell, known as the zygote. It's the starting point of everything. This seemingly insignificant cell holds within it an entire universe of information. Encoded in its DNA are all the genetic instructions, the complete blueprint, needed to orchestrate the development of a unique individual. It dictates your hair color, your eye color, and even influences how tall you might eventually grow. These are just a few of the many traits determined at this fundamental stage. The zygote's primary job? Divide and multiply. It's the first step in a rapid and precisely orchestrated process of cellular expansion. One cell becomes 2 through a process called mitosis. Then 2 become 4, then 4 become 8, and so on, in an exponential cascade of cell division. Soon, this rapidly expanding ball of dividing cells is called an embryo. After about a week of relentless division, the embryo transforms into a blastocyst, which then travels to the uterus, seeking a nurturing environment, and implants itself in the uterine wall. This marks the beginning of its new home for the next 9 months. This connection is absolutely critical. It's the lifeline that allows the developing embryo to receive vital nutrients and oxygen directly from the mother's bloodstream, fueling its rapid growth and development. Once securely implanted, the cells embark on a new phase of organization, starting to arrange themselves into distinct layers. Each of these layers is destined for a specific and specialized job in the developing body. One layer, known as the ectoderm, will eventually give rise to the skin. the intricate network of nerves, and the complex structure of the brain. Another layer, the endoderm, forms the foundation for essential organs like the stomach, the lungs, and other vital components of the digestive system. And a third layer, the mesoderm, is responsible for the development of muscles, strong bones, and the crucial organ that is the heart. From what began as a simple, unassuming ball of cells, a complex, multi-layered structure begins to emerge, taking shape with astonishing precision. The genetic blueprint is now being actively read and interpreted, and the construction crews of cellular machinery are diligently getting to work, building the foundations of a new life. The incredible journey from a single cell to a tiny but highly organized team of specialized cells is now fully underway. As the embryo grows rapidly, undergoing countless cell divisions and differentiations, the basic body plan is meticulously laid out, establishing the foundation for all future development. This intricate process ensures that every structure forms in its correct location. Around week 3, the heart begins to form as a simple pulsating tube, a testament to the body's innate drive to sustain life. It then starts to beat rhythmically, one of the first organs to become functional, providing crucial circulation to the developing tissues. This tiny heartbeat is a powerful sign of life. The brain and spinal cord, the central command system, begin to form from the neural tube, a critical step in establishing neurological function. Limb buds appear as small swellings, marking the future sites where arms and legs will grow, allowing for movement and interaction with the world. Features like eyes and ears, essential for sensory input, start to take shape, allowing the developing being to perceive its environment. Each cell meticulously follows the genetic blueprint, a complex set of instructions with incredible precision, ensuring proper development and function. By the 8th week, the embryo has a recognizable heart, now more complex and efficient brain, with distinct regions beginning to differentiate. Arms, legs, now with defined segments, fingers and toes. Tiny but perfectly formed, still tiny, but unmistakably human, a miniature version of what it will become. At this point, with all major structures in place, it's called a fetus, marking a transition to a new phase of development. The fetal stage is primarily about growth and refinement, a period of maturation and increasing complexity. Organs mature, becoming fully functional and ready to support life outside the womb. The brain forms complex connections, laying the groundwork for future learning and cognitive abilities, and the fetus grows much larger, preparing for the demands of life after birth. It can move within the womb, kick, a sign of developing muscle strength, swallow, practicing essential reflexes for feeding, and even react to sounds, demonstrating the early stages of sensory awareness. This 9-month journey from conception to birth is a perfectly timed, complex dance of biology, a symphony of coordinated events. The genetic code, the instruction manual for life, guides every step from start to finish, orchestrating this incredible transformation. From a single cell, a fertilized egg, to a fully formed baby ready to face the world. It's a biological marvel, a testament to the power of nature. Did you know you once had a tail? Early human embryos have a small tail, a leftover from our evolutionary ancestors. It disappears by week 8. Your heart started beating before your brain was fully formed, around day 22. By the 19th week, you had unique fingerprints that will never change, not even for identical twins. Even in the womb, a fetus can hear and react to sounds by about 24 weeks. Newborns can recognize their mother's voice and even songs they heard before birth. Learning and experiencing the world starts months before birth in the quiet world of the womb. The story of your first 9 months is full of surprises. Studying embryos and fetuses isn't just fascinating, it's a window into our very beginnings. It's vital for health and medicine, offering insights into a healthy life. Understanding how a body is built from its earliest stages helps doctors prevent and treat birth defects. Discoveries like the importance of folic acid have saved countless lives. Embryology powers technologies like IVF, helping families have children. Studying how cells grow and specialize, how they form complex structures, gives us clues to fight diseases and repair tissues. The secrets to healing the body may be hidden in the way we first built it. From a single cell to a kicking, hearing baby, the journey of the first 9 months is a biological miracle. Every cell in your body traces back to that original zygote. The next time you see a newborn, remember the incredible journey that made it possible. Science lets us peek into this hidden world, replacing myths with facts and hope. Even with all we know, the process still inspires awe and wonder. The universe isn't just out in the stars. There's a universe of wonder inside every one of us. Science is awesome.